Welcome viewers. So in this video lecture, we want to cover some objective type questions, so that you may perform well in your examination. So see here that we want to apply delta on e raised to the power 6x. Okay. See what is the definition of delta? That delta of f of x. This is equal to f of x plus h minus f of x. Okay, so if you apply your this definition on this function, okay, e raised to the power 6x, in that case it becomes e raised to the power 6. Value of x now changes to x plus h minus e raised to the power 6x. Okay, so what can be taken common from this? We can take e raised to the power 6x common, so it is e raised to the power 6h minus 1. Okay, so see here which option is correct for this question. This option is correct. Okay, so A option is correct. Now we want to apply delta on log x function. Okay, so we again use the same definition. Delta of f of x, it is equal to f of x plus h minus f of x. Okay, so what is f of x plus h? This is log x plus h minus log x. Okay, so apply log m by n rule. So what is log m minus log n rule? It is log m upon n. Okay, so this is log x by x cancel, so it is 1 plus h by x. Okay, so log 1 plus h by x, log 1 plus h by x. So which option is correct? This A option is correct for this problem. Okay, now see the next problem. Next problem is this, that we want to apply e raised to the power 5 on this function. Okay, see we know this rule that if we apply e raised to the power n on our function, in that case this is equal to f of x plus nh. So here I am applying e raised to the power 5 on f of x. So it is equal to f of x plus 5h. So what is f of x plus 5h? It means that in this function you just change your x to x plus 5h. Okay, so I just change it to x plus 5h minus 2. So it is what? It is 3 times x plus 5h minus 2. So which option is correct? This option is correct. B option is correct. Okay, B option is correct. Now, if in your A set we have 3 elements, then number of element in A cross A. Okay, so this is equal to number of element in A cross number of element in A. Okay, so in A set we have 3 elements, so 3 into 3 it is what? It is 9. So this option is correct. Okay. Now, if in set A we have 3 elements, then we want to find total number of relation from A to A. See, total number of relation from A to A, it is equal to 2 raised to the power n square. So n value mean number of elements in the set. So 2 raised to uh, 2 raised to the power 3 raised to the power 2. Okay. So 3 raised to the power 2 is what? 9, and 2 raised to the power 9. You see that this option is correct. Okay. Now we solve the next problem. See, the question is this, that this less than type of relation, which of the following is true? Okay. See, clearly A is not less than A for all A belonging to the set. Okay, suppose set is A. So A is not less than A. It means that A comma A, uh, uh, this is not the member of relation. Okay, so relation is not reflexive. Okay, so if A is less than B, it does not imply that B is less than A. Okay, it does not imply. So it means that relation is not symmetric. Okay, transitive, yes, this may happen. Okay, because if A is in relation with B, okay, and B comma C, this is also the member of R, then A is less than B and B it is less than C. So ultimately we can say that A comma C, it is the member of the relation. Okay, So this relation is transitive relation. Okay, so this is correct. Now next is that in this relation we say that elements they are related if A and B are from the same state. Okay, so you see that A and A mean here they are same are from same state. There is no problem in this. So relation is reflexive. Okay. Now if A and B are from same state, then we can say it like this also that B and A are from same state. There is no problem in this. Okay, so you see that this relation this relation is not symmetric. Sorry, is not symmetric. This option is false. Okay, uh, this relation is not reflexive, but this relation is reflexive. You see that we have already checked that this relation it is a reflexive relation. Okay, so this this one is not true. Okay, this one is also not true. R is an equivalence relation. See, as the relation it is not a reflexive relation, so how can it be an equivalence relation? Okay, so this is not correct. Okay, now next one is that R is partial order. So in partial order relation is reflexive, but you see that this relation it is not a partial order relation also. Okay, why? Because you see that if A and B they are from the same state. Okay, mean two person they can be from the same state, but A cannot be equal to B. So that is why it is not partial order relation. So what I feel that there is some issue in the statement of this question. Okay, so I feel that this statement it is a wrong statement. Okay, now we proceed further and we solve other questions. So see, this is the one problem, okay, and you are asked the following questions, okay. So what we do, we draw the Hasse diagram for this, okay. So you see that the first element is 2, so right here 2. And then 3, 2 does not divide 3, so right here 3 also, okay. Next, 2 divides 4, okay, 2 divides 4. Next, uh, 3 divides 6. Okay, next element is 6, so 3 divides 6. Okay, but 2 also divides 6. 2 also divides 6. Okay, next element is 9. Okay, so 3 divides 9. 3 divides 9. Okay, next element is 12. So 4 divides 12. 4 divides 12. Okay, but 6 also divides 12. Okay, uh, next element is 18, so 6 divides 18, but 9 also divides 18. Okay, next element is 36. Okay, so you see that 18 divides 36, but 12 also divides 36. Okay, next element is 48. Okay, 48, so 12 divides 48. Okay, 12 divides 48. Next element is 60. Okay, so 12 divides 60. 12 also divides 60. Okay, no other element except 6 can divide 60. Okay, so you see that these elements they are in a relation. Now next element is 72. Okay, so 36 divides 72. Okay, now the question is this, that which element is greatest. Okay, see, greatest element is that element such that every other element is in a relation with that element. Okay, so see here, you cannot say that the 72 is greatest. Why? Because 48 it does not divide 72, so 48 is not in a relation with 72. Okay, so here we can say that the greatest element does not exist. Okay, what is the least element? Again, least element is that element which has the relation with every other element. So you see that 2, okay, it does not divide 3. and 3 it does not divide 2. So here we can say that the least element it does not exist. Okay, which elements are maximal elements? See, maximal elements are those elements of the Hasse diagram which are basically found at the top of the diagram, and these are those elements which are further not in relation with any other elements. So you see that this element and this element, okay, these are those elements which are not further in relation with any other element. So the maximal elements of this are 72, 60 and 48. Okay, now what are the minimal elements? Minimal elements, these are the uh, these are the elements which are found at the bottom of the diagram, and these are those elements below which you cannot find any element which is in relation with these elements. Okay, so 2 and 3 are those elements below which we do not have any other element. So what are the least elements here? Least elements are here, minimal elements here 2 and 3. Okay, these are the minimal elements. Okay, now upper bounds. Okay, upper bound of 36 and 60. Upper bound mean that you find those elements in this set, okay, which are divisible by 36 and 60 both. Okay, so the element which is bigger than 72, which is bigger than both these elements 36 and 60, it is only 72. Okay, but 36 divides 72 and 60 it does not divide 72. Okay, so what is the condition for the upper bound? That whatever element you say that element is upper bound, so both these elements should divide that element. Okay, so 36 divides 72 but 60 does not divide 72. Okay, so that is why we can say that it does not exist. Okay, now the lower bound of 6 and 3. See, lower bound mean tell us those elements of this set, okay, of this set which divide both these elements. So see, 3 is one such element which divide uh, 3 and 6 both. Okay, you cannot find any other element which divide both these elements. Okay, so here we can say that the lower bound of this set is 3. Okay, so this is all about in this video. So we will solve some more objective type question in the next video lecture. Thank you very much viewers for watching this video.